Hey guys, hope you're doing well. So here we have the 2024 Matric mock exam written in the Gauteng province. It's Mathematics Paper 1, 3 hours long, 150 marks. If you would like to download this paper, then just check the description below this video. Given that 2k is equal to these two brackets, determine k if x is equal to 2. Okay, so that's quite an easy question, but it is weird, like it's different. So what we know is that they're telling us that x is 2. So we're just going to go plug in a 2 at both of those positions over there. And so you'd end up with 2k is equal to 2 take away 5, 2 take away k. And then we're just going to simplify. So what is 2 minus 5? It's negative 3. Some learners probably would have wanted to multiply out. Nothing wrong with that. 2 minus k. 2k is then equal to negative 6 and then plus 3k. And now we're just solving for k. So I'm going to take the 2k over to the right-hand side, and I'm going to take this over to the left. So you're going to end up with that. And so 1k is 6. So 1k just means k, so k is 6. This one says calculate x if k is 2. So now we're going to restart the whole question, okay? So now what we're saying is that if we have 2k equals to x minus 5 and x minus k, now we're going to replace all the k's with 2. So we're going to put a 2 over there and a 2 over there. So we're going to say 2 times 2 equals to x take away 5, and then x take away 2. Okay, so this just gives you 4. Here we're going to multiply out. That will give you x squared minus 2 minus 5. That'll become minus 7x eventually after you've put all the like terms together. And then 5 and 2 is going to be negative 5, and negative 2 is going to give us positive 10. Whoops. Okay, so now it just becomes a trinomial. So I'm going to take everything to the right-hand side. Now 10 minus 4, that's going to end up becoming a 6. And now we can factorize. Or if you wanted to, you could use the quadratic formula. This would end up being x take away 6, x take away 1. Because minus 6 minus 1 gives us minus 7. And then you can then say that therefore x minus 6 is 0, or x minus 1 is 0. Therefore, x is 6 or x is 1. Okay, here they want us to solve for x. So they're saying correct to 2 decimal places. So that automatically means we're just going to use the quadratic formula. And so there we have the quadratic formula. And so just remember that we first need to rearrange this to make one of the sides have a 0. So I'm going to bring that 8x over like that. Now remember that the number in front of the x squared, that is your a. The thing in front of the x, that is your b. And then the other number is the c. So we're going to go plug that in now into this equation over here. So it's going to become x equals, now you see there's a minus over here. Then our b value is also a minus. So I would put that in a bracket. Then there's a plus minus. Now in the b squared part, I always put that in a bracket. It's especially important when there's a negative for b. Minus 4. What is a? A is 2. What is c? C is 3. And then that's all over 2 times a, which once again is 2. Now from here, you can go straight to your final answer. They just want you to see that you substituted the right values. You do get a mark for that. You also got a mark for this part over here where you make it equal to 0. And then, okay, I shouldn't be ticking all of those because you think that's all marks. Okay, so there's a mark there. You get 1 mark for this part. And then now you can just go plug into the calculator. And so to 2 decimal places, that would be 3.58 or 0.42. And so you get a 3rd mark there and a 4th mark there. And that's why it's out of 4. Solve for x. Okay, so here we have a square root equation. So what we do is we try to get this part by itself. So all I'll do is I'll take this 10 over to the other side. And so we're going to end up with this over here, where it'll become a plus 10. Now minus 12 plus 10, that's just going to give us negative 2. So let's just quickly go write that down. Negative 2. Okay, now all we do now is we square both sides. So what that means is you put a nice bracket around all of everything you see. what you mustn't do is don't go do this. Okay? You rather do that. Now what we must remember is that this square completely gets rid of the square root. And so all that you are left with is whatever is inside the square root, like that. If there was a little 2 over here, you would leave it over there. Okay? All that this 2 does is it just removes the root. It doesn't remove any of the little 2's or anything like that. And then on the right hand side, we're going to double bracket this. What would be wrong is if you then say it's x squared and 2 squared. No. Because there's more than one term over here, we're going to double bracket. And now we're just going to simplify. So 2x plus 20, because I multiplied that in. And then x squared minus, this will be eventually become minus 4x plus 4. Obviously, you might say minus 2, but it will eventually become minus 4. I'm going to take everything to the right-hand side. We're going to have that over there. And then we're going to end up with minus 6x minus 16. Okay, now this can factorize, but if you wanted to at this point, you could use the quadratic formula. But this can factorize into x take away 8 and then x add 2. Because minus 8 plus 2 gives you minus 6. And then minus 8 times 2 gives you minus 16. And so then we can say that x minus 8 is 0, or x plus 2 is 0, so therefore x is 8, or x is minus 2. Now this, up to this point, you would only get 3 marks. What we must remember is that when you have a square root, we should always do a little check at the end. So let's go show the teacher that we're going to do a check. And this is an easy process. All that you do here is you plug in the first number. So you plug in the 8 onto the left and the right side. So let's see on the left hand side, and then we'll see what it is on the right hand side. So we're going to go plug in the answer, which was 8. And so that'll give us that. And if you just had to go chuck that on the calculator, that would give you negative 4. And if you go plug that on the right hand side, it would be, so now I'm plugging into this side, that would give you 8 minus 12, which is also negative 4. So the left hand side is equal to the right hand side, and that is what we would like because it says that they're equal. So there's no problems with that one. Let's go see this one now. So now we're going to go plug in minus 2. So on the left hand side and then on the right hand side. So on the left hand side, we're going to get 2 times negative 2 plus 10, take away 10. And that'll give us negative 6. And then if we plug on the right hand side, that'll give us negative 2 take away 12, which is negative 14. So the left side and the right side are not the same. So mathematically, this one is giving us a bit of a problem. And so you would just put a line through that one over there. Okay, so you just put a line through it like that. This question is only for 2 marks. So the way that it works is they want to know, where is this expression smaller than 0? So where is that expression negative? So I want you to look at this as 2 parts, okay? So there's this part and there's this part. Now, if you look at this part over here, 3x, no matter what x value you ever put in here, this expression can never become negative. You can go try that out. You can plug in any x value you want. You will never, ever, ever be able to make this expression negative. Why? It's actually an exponential graph, that one over there. It's a normal exponential graph where it just goes like this. So can you see all of the... okay, so remember that this is your x-axis. So can you see that for any x value, even if we make the x value very negative or if we make the x value very positive, can you see that the y value at any point is always a positive number? There's nothing over here. There's no y value down here. So for any x value, like maybe this is minus 2, maybe this is minus 4, maybe this is minus 8, maybe this is minus 1,000. It doesn't matter what x value you use. And maybe these x values here are 3, 6, 9, 12. No matter what x value you use, the y values are always going to be something positive. You can see from even this dot over here, it's never going to go underneath and make a y value of negative. So what we'll say to the teacher is that this part over here is always positive for every x value that you can ever imagine. So we will say that 3x is always positive. That's how you say 3x is always positive, or 3 to the power of x. You say that it's always bigger than 0. That means positive. For all x is an element of R. So what that means is for all x values in the real number system. Okay. So if we know that this part here is always positive, now we can look at this part over here and we can see, or we can better understand what that part would need to be so that this whole expression is smaller than 0. So that this whole expression means that that will then be negative. So we know that if this part here is a positive, then that means this part over here would have to be what for this whole expression to be a negative? Well, we know that a positive multiplied with a negative will give us negative. So we're going to say that we would like the x minus 5, we would like that to be negative. That means it must be smaller than 0. And now you can just take the 5 over, and so x must be smaller than 5. And so that is our answer over there. X must be smaller than 5. So simultaneous equation, what I always say is find the most easy or simple expression. So that would be this one. And then try to get x or y by itself. So we'll call this equation 1, we'll call this equation 2. And we're going to get x by itself over here. There we go. Now we'll call that equation 3. What you now do is you take this expression and you're going to substitute it into this one. I'll show you how to do that now, but let's just say here, substitute number 3 into number 1. Okay, so remember that what this says here, it says that x is the same as this. So what we're going to do is we're going to replace that with 6 minus 4y squared. So we're going to have 3 to the power of 6 minus 4y squared, and then the 9y, oh, that's not a g, 9y equals 27. Okay, now remember, when you have something with a square root, it's the same as saying that it's to the power of a half. Okay, now, if we go back to exponent rules, if you have something like this, what do you do with these two things? You multiply them. So what are we going to do with all of this? We're going to multiply. So I'm going to multiply the half with the 6, so that'll become 3. And then I'm going to multiply the half with the 4y squared, and so you're going to multiply the half with that 4y over there, and that's going to become 2y squared. Okay, it's a bit of a weird one because you might be tempted to multiply those two, but this is the exponent of this exponent, so it's a bit of a weird one. But there you've got that, and then here we've got 9y, and here we've got 27. So what I'm going to do now is I'm going to replace this with, change this 9 to 3 to the power of 2, and I'm going to change this 27 to 3 to the power of 3. And so we're going to end up with 3 to the power of, let's write it up here, 3 to the power of 3 take away 2y squared multiplied by 3 to the 2. So that's the same as 9. And then 27, I know that that's the same as 3 to the 3. Now using exponent rules, I need to multiply those two together. Okay, now don't multiply these two numbers together. Think about exponent rules. If you have a to the 3 times a to the 2, well, that means you add, so it becomes a to the 5. So this will become 3 to the power of 3 take away 2y squared plus 2y equals 3 to the 3. And now you've got 3's on both sides, so they can cancel out. And so now we end up with that over there. And so now these 3's over here, they would cancel out. And so you just end up with minus 2y squared plus 2y. I would take out a 2y as a common factor, and you'd be left with negative y plus 1. And so if you had to now go solve this, you would say that 2y is 0, or minus y plus 1 equals to 0. And so if you had to solve this one, you would end up with, therefore, y is 0, or, and then if you solve this one, you would end up with y equals 1. Okay, so now we have our y answers. So now we need to go get our x answers. So let's quickly just make some space over here. And so we know that y is 0 or y is 1. Okay, so when y is 0, let's see what x is. So you plug it into this equation over here. So x would then be 6 take away 4, y is 0. And so x would then be 6 minus 0, which will just give you 6. And then if y is 1, then x would be 6 minus 4 times 1, which would be 6 minus 4, which would then be 2. The solutions of a quadratic equation are given by this expression over here. State the values of p for which this will have. Okay, so this is going into the theory of nature of roots. And remember, nature of roots only looks at, you know how you have the quadratic formula? Can you remember which part is important for nature of roots? It's the part inside the square root. It's not the square root, it's the part inside the square root. We call that the discriminant. It's the b squared minus 4ac. And there's a bunch of things we can talk about when we, depending on what that value is. If that value inside the square root is a negative, then we say no real solution. If that value is anything positive or anything 0, we call that a real solution. Okay, now within the real solution, there's 3 main types you can get. If the answer is a 0, then we call it 2 equal solutions. Okay, if the answer is a square number, like 25, 36, 49, square numbers, 7 squared, 8 squared, 9 squared, then we call it 2 rational solutions. And then if you get any other number like 17, 21, 15, any number that's not a perfect square, then we say 2 irrational solutions. Okay, so what you need to identify here is that this part here, this part that's under the square root, that is going to be our b squared minus 4ac. Okay, so they said state the value of p so that we'll have 2 equal solutions. Well, that's this one. So for 2 equal solutions, you want the b squared minus 4ac to be equal to 0. So we're going to say 2p plus 5 must equal to 0. So 2p plus 5 equals to 0. And then you're going to take the 5 over to the other side. And then you're going to divide by 2. And there we go. So that is what p must be so that we get 2 equal solutions. Now what about no real solution? Well, there it is. So we want the b squared minus 4ac to be negative. How do we say that something's negative? What you do is you say that the 2p plus 5 must be negative. Negative means smaller than 0. And now you just solve. So you take the 5 over to the other side, divide both sides by 2, and there's your answer. Some of you might have thought we have to switch this around, but that's only if we divided with a negative number. But we didn't divide with a negative number. The 2 is a positive number. Given the quadratic sequence, so the first question says write down the value of the 4th term. Okay, so what we have is we've got 0, 5, 14, and then, okay, so then there's a gap over here. All right, so let's see what happens. So we know that difference is 5. That difference is 9, because 5 plus 9 gives you 14. We know then that this would be 4. Now, because it's a quadratic, we know that the second difference remains constant. So we know then that this must be a 4, which means this would have to be 13, because 9 plus 4 is 13. And so 14 plus 13 would then give us 27 over here. So the answer must be 27. It's only 1 mark, so you can just write it like that. Now it says determine an expression for the nth term. So this should be full marks for all of you, because we know that the formula is an squared plus bn plus c. Now we know those 3 formulas that we always use: 2a, 3a plus b, and then a plus b plus c. Okay, so we start at the bottom, and it says that 2a is 4. So then if you had to get a, it would be 2. Now we go to the next one. 3a plus b equals to 5. So we fill in a as 2, and then we're going to say 6 plus b is 5. And then b would be 5 minus 6, which is minus 1. Then we use this one over here. So a plus b plus c equals to 0. So a is 2, b is minus 1. And so if we had to solve, we would eventually get that c would be equal to 1 minus 2, which is negative 1. And so your final answer there, well, we'll double check it now, but it looks like it's going to be 2n squared minus 1n minus 1. And so now we need to go and do a safety check to make sure we've done it correctly. So for example, if we look at this one, that is term number 1, 2, 3. So what I'll do is I'll go plug a 3 into these two over here, and let's see what we get. That'll give us 14, and the correct answer is 14, so then we can be sure that this is correct, what we've done. Okay, sometimes you might get a different answer, then it just means you've made a little mistake. Maybe you forgot to put a minus or something like that. This last one says, calculate the number of terms. Okay, so we know our formula now. We know that the last term is 860, so we can say that 860 is equal to this. And now we're just going to go work out the position of the 860. But because that's the last term, it'll also be the number of terms in the sequence. And so here I'm going to put a 0 over here, take that all over, minus 861. Now here I would definitely use the quadratic formula, but now instead of x, we're looking for n. So we could say n equals. Okay, now remember, this will be a, b would be negative 1, and then there would be c. It's a different a, b, and c to what we found here, by the way. It's the a, b, and c that we normally talk about in quadratic formulas. And so we end up now with n equals to, okay, so that says negative. Now b is negative 1 from over here, plus minus. B is negative 1. A is 2. C is negative 861. And then a once again is 2. And then, okay, so now you can just go calculate. You'd get n as 21, or n is negative 20.5. Now remember what n is. N is a position, so you can't have a negative position, so we're going to cross that one out. And it also can't be a decimal number. N is a position, so it's position 21. So this is position 21, but because that's the last term in the sequence, we can also say that there are 21 terms in the sequence. Determine the sum of the whole numbers between 100 and 1,000, which are divisible by 11. Okay, so we've got the numbers 100 all the way to 1,000, and they're saying all the whole numbers. That's just normal numbers. 101, 102, 103, 104, 105. You get the idea, right? 110 all the way to 1,000. Now they want the ones that are divisible by 1,000. They want the ones that are divisible by 11. So we know that if you count in 11s, 11, 22, 33, 44, 55, 66, 77, blah, 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 you'd get to 99, then you'd get to 199, you'd get to 110. So that's the first one. Then what is the next 11 after that? Well, that would be 121, then 132. Now, we can pretty much stop there because after these three, we already have a pattern. Now, we got to figure out where the last term would be. So is the number 1,000 divisible by 11? Well, no, you can try it on your calculator, it won't work. So then what is the number that comes before 1,000? 999. Now that is divided or is divisible by 11. And that number is also not divisible by 11. Then you can try 998. Say 998 divided by 11 on your calculator. Also doesn't work. Then we go to 997. Let's see if that can divide by 11. No, it can't. Then I'm going to go 996. Doesn't work. 995. 994. 993. 992. 991. Come on. 990. 990 works. Okay, so 990 is the biggest number we can get in this sequence that is divisible by 11. So that'll be the last term in this sequence over here. Okay, so from this, we have more than enough information to be able to calculate the sum. First step is we need to know, is it arithmetic or geometric? Well, we're adding 11 each time, so that is arithmetic. Okay, so we know that. Well, there are two formulas in arithmetic. There's the normal one, and then there's the other one, which is n over 2 a plus l. So I typically hardly ever use this one over here because you're still going to have to go work out the number of terms. So I tend to just use this normal one over here. Now we know how to calculate the sum of an arithmetic pattern. It goes like this. Okay. Now we know what A is. A is term 1. You don't use this A. We are talking about this sequence. So this is A. D is 11. And we know we know the difference. We don't know the number of terms. So what we do is we use this formula now for an arithmetic. And we look and see how many terms there are. So if we know that this is the last term, we can put 990. Then A is 110. And then the difference is 11. Now you see the only unknown is how many terms there are. And so now we can just bring this 110 over. There's many ways you can handle this next part. I'm going to multiply the 11 into the bracket like that. And we now have 880 on the left, 11n minus 11. Take the 11 over, it becomes 891. Divide both sides by 11, and you get 81. So there are 81 terms in this pattern over here. Okay? So we can say the sum of 81 terms, so A is 110, 81 terms, and then the common difference is 11. And you can just type that on the calculator, and that'll be 44,550. Given the geometric sequence, determine the value where the sequence converges. Okay, so we've made videos on this, right? We know that a sequence converges when r is anywhere between -1 and 1. So what we'll do now is we need to go work out r. Now we know that r you can just get by saying term 2 divided by term 1. So that would be term 2, which is this one, divided by term 1, which is this one. Okay, now remember, the 4 and the 8 can cancel. So 4 goes into itself once, and 4 goes into 8 twice. Now, some learners are going to be very comfortable with this, but some of you might struggle. So remember, this 3 means that there are 3 of those brackets. This is only for the learners that are struggling, that I would write it out like this. And then at the bottom, you've got a 2, and then there's 2 of them. So you can cancel 1 at the top with 1 at the bottom, and then 1 at the top with 1 at the bottom. And so what we are left with then is, at the top you've just got x minus 2. You can ignore this 1, it doesn't really do anything. And then at the bottom you've got a 2. So that is your r. So I'm going to now put that over here, x minus 2 over 2. Okay, now we're going to multiply this 2 over on either side. Some learners always ask me, they're like, Kevin, do we need to switch the signs? The only time we switch the signs is if we multiply or divide with a negative number, but this is not a negative number, this is a positive number, okay? We're not talking about this number, we're talking about the one that we're going to move. And so we're going to multiply it there, and we're going to multiply it there. So that becomes that, and then we end up with a 4 on this side, because I took the minus 2 here, but then I also have to take the minus 2 there, so it'll become minus 2 plus 2, which is 0. And so that would be the answer for that question. X must be anywhere between 0 and 4. They're saying now that if x is 2.5, calculate the sum to infinity. Okay, so we know that the sum to infinity formula is a very easy formula to use, which just goes a over 1 minus r. Okay, so a is term number 1, which is this one over here. So we're going to have to go work that out, because they've told us that x is 2.5. Okay, so that's going to be like that. And so that'll end up giving us 8 times, you can actually just type that in the calculator, to be honest. That'll give us 2. So a is 2. Okay, and then r, we're going to have to go work that out. We know that that is x minus 2 over 2, which we looked at earlier. And so that's going to give us 2.5 minus 2 over 2. And that will end up being, you can just type this on the calculator, a quarter. So r is going to be a quarter. So we're going to just say like that. Okay, and then you can just go type this all in. And we end up with 8 over 3 as our final answer. 8 over 3. Okay, so here we have a sigma notation, and the first question says, how many terms are there? Now, a lot of learners are going to get this wrong because they're going to say that it's this number over here. But remember, what I've told you is that to work out the number of terms, you always take the top minus the bottom, and then you add 1. So it's going to be 12 minus 3 plus 1, and that's going to give us 10 terms. Let me show you. If you start at the number 3 and you count all the way to 12, then how many terms do you see? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So what teachers get, the way that teachers confuse you learners is they always give you examples in class where this is a 1. If that number is a 1, then when you do this expression over here, you're going to get an answer of 12. And so learners think, oh, so that's the number of terms. But it's not true. It's only when this number at the bottom is a 1, then it's just a coincidence. Okay? So rather just remember this. Okay, so we know that there's 10 terms. Now it says calculate the sum. So to work out the sum, think about this. We know that there are two main patterns, arithmetic, geometric. We need to always be able to find which one it is. And to do that, I always tell learners we need to go find the first 3 terms. So to find term 1, you will plug in whatever this number is into the place of k. So that's going to give us 3 and then 3 minus 2, and that'll end up giving you negative 6. Okay, now to find term 2, you're going to increase this number by 1. So now you're going to plug in a 4 like that. And so that'll give us 12. Then to find term 3, you're going to plug in the next number, which will then be a 5. And so you're going to say 5 minus 2. And so that'll end up giving us negative 24. And so if we now look at the first 3 terms, we've got this, this, and this. Now that's definitely not going to be arithmetic. But if we look at the r value, we could work out by saying 12 over minus 6, and that'll give you minus 2. Then, if we say minus 24 divided by 12, that's also minus 2. So can you see that the ratio is remaining constant from this term to this term, and from this term to this term? The ratio is remaining constant. So it's a geometric. Okay? So to calculate the sum of a geometric, you can use this formula. Let's write it over here. Now, some learners use 1 minus r, other learners use r minus 1. It doesn't matter. As long as whichever one you choose at the top, you must use that one at the bottom. Okay, so we know that the sum of 10 terms, a is always term 1, which is negative 6. R is negative 2. N is the number of terms, which is 10. And then R again is negative 2. So I'm going to go ahead now and just type that all in on the calculator, and that'll give 2046. Just don't put these two as a positive, because remember this part here has this exponent, and so it's almost locked. So you can't put this negative inside there. Okay. The graph of f of x equals to ax squared is sketched below. Okay, so this is actually a parabola. That over there is a parabola. The only reason it looks weird is because we don't have the other half over here. The reason we don't have the other half is because they have restricted us to that over there. So they're only looking at the areas where x is smaller than 0. So that is all of this on the left-hand side of here. So we don't have anything on the right-hand side. The point P lies on the graph. Okay, calculate the value of a for 2 marks. Okay, so that's easy. So we know that f of x is equal to ax squared. So we can just go plug in. Remember, this is like a y, so you could even just say y equals to ax squared. So this is a y, and that is an x. And so you could go plug that in as minus 8 equals to a, and then x is negative 6 squared. And so minus 8 is equal to 36a. And then to get a by itself, you would say minus 8 over 36. And then that's quite a weird value, actually. It's going to be negative 2 over 9. Okay, so a is going to be negative 2 over 9 after you simplify that. So negative 2 over 9. Okay, now it says determine the equation of the inverse. Okay, so we know how to do inverse, right? We take the original equation, which is y equals to negative 2 over 9 x squared. Then your first step is you switch x and y around, like that. Then you got to get the y by itself. Okay, so the first thing I would do is I would take these over. Now there's multiple ways you could do it. You could take the 9 over first, which would go to the top, and then the 2 would go to the bottom. So you could say like that, okay? Equals to y squared. And then to get the y alone, you would obviously take the square root. Oh, and then I'm forgetting about the restriction. So because we had x is smaller than 0 over here, then because we switch x and y around, then we should have a restriction that says y is smaller than 0. I do see, though, that on a lot of the memos, if you forget to put this part, they don't penalize you, okay? And now, okay, so now we're going to take the square root. Now, normally we would say plus and minus whenever we take a square root, but we got to be careful now. Sorry, that's negative 2. You can write it in different ways. You could write it as like that. You could put the negative next to the 9. It doesn't really matter as long as there's a negative somewhere. Now, we've got to think about this. We know that whatever's inside a square root is never allowed to be negative. It must always be positive. So this part here is positive. But they told us here that y must always be negative. So do you think we're going to use the plus or the minus in the front? Well, it's definitely going to have to be the minus. Because we know, because normally you'd say plus and minus, but they've told us from the restriction that y must be negative or 0. So because this part always has to be positive, otherwise you get you get like an error on your calculator whenever the square root is a negative, then we know that this part here is always positive. So that means this part here would always have to be, or this part here would have to be a negative, so that it makes this entire expression a negative. Okay, so there is the answer for question 4.2. And then just one more thing, obviously we wouldn't write it as y, you would change it to f of x with the inverse symbol. So you'd put like a little -1 there. So let's just write our final answer. It's going to be f negative 1 of x is equal to the negative of the square root of 9x over negative 2. Write down the range of the inverse. Okay, so we know that range, okay, well, when we're talking about inverses, we know that if you have f of x, and then if you have the inverse, we know that x changes to y, and y changes to x. We know that they switch around, right? So that also means then that the domain also switches with the range. So they're asking us for the range of the inverse. So that would just be, if you look at the domain of if we look at the domain of the original graph. So if you look at the original graph, what is its domain? Well, we know that x can only, domain is x. So x is only allowed to be smaller than 0. So the range would also be smaller than 0, but because it's range, you would say y. Oh, and then let's say here, y must be smaller than or equal to 0, like that. Okay, for that, sorry, that was for that previous question. So for this next question for 2 marks, says sketch the graph of the inverse. Okay, so that's easy because we know that with inverses, the x's and the y's change. So we can use this point over here, and we can use this point over here, which is 0, 0, and we can just switch the coordinates around. So we know that -6 minus 8 will now become -8 minus 6. So that would be minus 8, minus 6, so maybe over there. And then 0, 0, well, that would end up still staying over there. And so you got to also just remember your basics of parabolas. So we know that parabolas are like that. And then if you had something like that, the inverse would usually go like that, right? Now, if you have an upside down parabola, then the inverse would typically go like that. But now we only have, so we can see with this dot and this dot, so we just have this part here. So we're just going to go like that. Okay, and we can put the coordinates, minus 8, minus 6, and that's everything. So indicate the coordinate of any point in the graph different to 0, 0. Okay, we've done that. We've got this one over here. Now, the graph of f, which is this original one that we've got over here, is reflected across the line y equals to x. Do you know what that means? Reflected across the line y equals to x. That means inverse. That means inverse. And thereafter, it is, so when it's reflected across that line, it's the inverse. So it's actually this one. Now it's this one we're talking about. So after that, it is reflected across the x-axis. So it's this graph now reflected across the x-axis. So it would actually end up going like this. Sorry, let me do that a bit better. It would end up going there. Okay? So what they want us to do is determine the equation of the new function. Okay, so we know the inverse function already. It's this one over here. So we know that the original inverse function is that one over there. Now, when you reflect across the x-axis, the y value changes, right? For example, if you have this point over here, let's say this point is 3 and minus 2. If you reflect it across the x-axis, it just becomes 3 and positive 2. So the 3 stays a 3. You see how the x values stay the same. So all that changes is the y value changes. So the y value becomes the opposite of what it was. So I'm going to make the y value the opposite of what it was. So there I've just made it a negative now. And then I'm just going to get the y value by itself. So the only way I do that is I can just cancel these negatives on both sides. And now we end up with that. And as I said, this negative can also be in the front over there. It can be up by the 9, as long as you have one negative there. The point P lies in the Cartesian plane. Okay, let's go fill that in. I found this when I read this question. This is a really random question. Like, this actually touches on, I don't know if you remember, like in grade 9, where you would have done things like translation, rotation, reflections. Remember this whole 90 degrees anti-clockwise? That's pretty random that they're throwing it into, this is a grade 12. This was part of a grade 12 exam paper, so very interesting. Okay, so the point 2 and square root 3, so that would be like somewhere over here. 2 square root 3 lies in the Cartesian plane. Determine the coordinates of the image if it is rotated about the origin through 90 degrees anti-clockwise. So you need to just know that anti-clockwise means this way, okay? So we're going to rotate it 90 degrees. So 90 degrees would put us like somewhere there, okay? Now, what you must understand when you rotate 90 degrees is that you're going to switch these around. So switch those around first. So 2 square root 3 would now turn into square root 3 and 2. But now, if I put square root 3, 2 here, which of these coordinates is wrong? Well, think about where you are on the Cartesian plane. In this area here, you would want your x's to be negative. So your x's are negative there, and your y's are still positive. And so that would be the answer over there. So this is the answer. Okay, so they've given us an exponential graph over here with a point on the graph. Now it says substantiate why the coordinates of Q are 0 and 1. Okay, well, we can actually just go solve for the y-intercept. To find a y-intercept, you make x 0. So if you make x 0, then have a look here. Anything to the power of 0 is 1. So y would then be 1. So therefore, your coordinates of q would have to be x is 0 and y is 1. Now it says calculate the value of a. Okay, easy, because we have this original a to the x, and we can just say y. Now we have a point, so we can put the minus 1 as x and the half as y, right? Because that's a x and that's a y. So we could say half equals to a to the minus 1. Now, there are multiple ways that you could, well, let's just think, do I actually, yeah. So what we must understand is that there's a minus 1 is the same as, or there's so many different ways. For example, what is another way we could write this? Would you agree you could write it as 2 to the negative 1? Now all of a sudden you've got the same exponents on both sides. When that happens, you can then cancel those, and then 2 would just be a, or a would just be 2. An alternative way you could have solved this is the following. So we know that a minus 1 is 1 over a. You could then cross multiply, so you could take that over there and take that over there, so you'd end up with a equals to 2 as well. So however you want to do that, okay, but the answer is 2. Now it says write down the equation of the inverse of that equation. So the original equation is h of x equals to a, which is 2 to the power of x. So with inverse, we're just going to do that. First step, switch x and y around. Okay, now you got to get y alone. So this is where you would use logs. So you're going to say y equals to log of the base to the power, or not to the power, but just you're going to put x over there. And that would be the final answer. But they said in the form h minus 1, so you could then say h minus 1 of x equals to log 2x. Remember, an exponential, when you take its inverse, it becomes a log. This one says, draw a sketch graph of h, indicate the coordinates of 2 points that lie on this graph. Okay, very easy. So we can literally just take this coordinate here and this coordinate here and switch them around, because that is what inverses do. So if we take minus 1 and a half, well, that'll now become a half and minus 1. And if we take 0 and 1, well, that'll now become 1 and 0. So let's go plot those points. So this will be a half and minus 1, which would be like there. And then this 1 and 0 would be something like that. And then you just need to know what a log graph typically looks like. So you must know that if an exponential does that, then the log does that. Okay? So it's going to run like that and like that, or more like that. So it runs along the y-axis like this. Okay, and then just fill in those coordinates because they've asked us to do that. So this would be 1 and 0, and this would be half negative 1. Now it says read off from your graph the values of x for which the function is bigger than minus 1. Okay, so here is minus 1, the y value of minus 1. So it's this one here, right? So that line there is where y is minus 1. So they want to know, where is this graph bigger than that? So where is this graph above that? Well, where is it above that? If we go to the left, we can see that if we go to the left of this point, then we see it goes below. See that? If we go to the right of this point, then it goes above. It goes above this line. And so they want to know, where are we above? So that's going to be all of this. And so it's when x is to the right of a half. So when x is bigger than a half. So you could say x bigger than a half. If you prefer interval notation, you could say x is an element going from half to infinity. This last one says that if g is equal to that, determine the values of x for which h is equal to g. Okay, so let's go have a look at this weird looking question. So we're just going to make h equal to g. So h of x equals g of x. And so h of x is our original equation, which was 2 to the power of x. Or it was ax, but we know that a was 2. And then g of x is 100 times 3 to the x. Now you can't make this 300 because there's an exponent. So What we could do is, for example, we could divide by 3x. So we could end up with 2x over 3x equals 100. Now, when these two are the same, we can actually rearrange that to become 2 over 3 to the x equals 100. And then I would use logs from here. So you would get that one is equal to the log of the base and then this number. And then that you can type on your calculator, and that would be negative 11.36. The price in rands per unit of each item in a consignment of Q items is given by this. Okay, so calculate the value of P and the total price of the consignment when the consignment has 1,980 items. Okay, so 1,980 items is going to go there because that's items. So P would then be log 10 plus 1980 over 2. And that would be 3. That just gives you 3. But now be careful. It says calculate the value of P, which is the price in rands per unit. Oh wait, no, we've done that. So okay, so that's P, so that's per unit, rand per unit. And then what is the value of the whole consignment? Well, the consignment has 1,980 items. If each item is 3 rand, then you could just say 1,980 multiplied by 3, and that'll give us 5,940 rand. Okay, so P is 3, and the consignment is 5,940 rand. Okay, now it says determine the number of items in the consignment when the price of each item is 2. Okay, so now what they're saying is that the P, which is rands per unit, and now its price per unit is 2 rand. So they're saying P is 2. So we're going to go 2 equals log 10 plus Q over 2. Okay, now remember that when you have a log like this that doesn't have any number over here, then it's actually a 10. There's actually a 10 there. That is the standard of a log. And so here we can just reverse log and turn it into an exponential. So you take the base to the power of the other number, and then just make that equal to whatever's inside here. So we can just say 10 plus Q over 2. So then 10 to the power of 2 is 100. And so you take the 10 over, so it becomes that. And then you can just multiply the 2 over, and so Q would be 180. Sketched below is the graph of minus x plus 4, which is a straight line, and the hyperbola. Write down the domain of G. So when you look at the domain of a hyperbola, let me just draw a random hyperbola for you. Let's say, for example, we had that, and it says here x equals to 2. This is just an example. And then you had something like this, and then let's say you had that, and it said y equals to minus 1. When you look at the domain, it's all the x values. So all you're going to say is that x can be anything. See here, x can be absolutely anything. If you look along the x-axis, it can be anything you want. But the only thing that it can't be is the graph never ever touches this part over here. So for a hyperbola, you will always say x is an element of all real numbers, but x is not allowed to equal to whatever the asymptote is. Now on our graph, it's at -1. How do I know that specifically? Because if I look at this, I know that that part there gives me my asymptote. If I make that part equal to 0, then it gives me my x asymptote. And if I make y equal to this number, that's my horizontal asymptote, which would be this one here. Okay, and so x cannot be -1. Now it says write down the equations of the asymptotes of G. Well, there we have them. X equals to -1 and y equals to 2. Calculate the coordinates of point D, which is the place where the two graphs intersect. Okay, for 5 marks. So most of you are probably going to get like 3 marks at least for this question, because we know how to find the point of intersection of two graphs. You just make them equal. So we're going to make this expression and this expression equal. So, and you would get a mark for that already. Okay. Now, I'm just going to simplify the 4 and the 2. So I'm just going to take everything. Well, I'm going to take the 2 to the left. So you're going to end up with that. Okay. Now, there's multiple ways you can think about this. But what you need to realize is that we have fractions over here. So you need a common denominator. So your common denominator will just be x plus 1. So we'll multiply everything with x plus 1 like that. And then equal to 2. You don't need to write the denominator because we have a equation. Another way you could have done that is, you know how we had this part over here where it was minus x plus 2 equals to 2 over x plus 1. Well, what you could have done is just multiplied both of these like that with x plus 1. So it would have gone like that. This and this, it's actually going to give us the exact same thing at the end of the day. Okay, so I'm going to go multiply this out now. So that'll be negative x squared take away x plus 2x plus 2 equals to 2. These two can both cancel. And so on the right hand side, we're now going to have a 0. So we're going to have minus x squared minus x plus 2x equals 0. Now, this minus x and plus 2x, that just becomes x. So we can say minus x squared plus x equals to 0. Don't take this to the other side and then divide with x. We don't want to divide with variables. Rather take out an x as a common factor. You're then left with minus x plus 1. And so then you can say, therefore, x must be 0 because of this one. Or minus x plus 1 must be equal to 0, which means x would then be 1. So x is either 0 or x is either 1. So here we can see where the two graphs intersect. We can see that they intersect at A. That is where x would be 0. And then at D is when obviously x would have to be 1. So they just want the coordinates of the D one. So we've got x as 1. Now we just need y. So how do we find y? Well, we know that the straight line goes through that point and the exponential goes through that point. So you could use this equation or this equation to find y. And so we want to know what is y when x is 1. And that would give us 3. And you can even see on here it's 3. So you know you're correct. And you could see from D over here that it's a 1. But at least now we have calculations to show that. There we go. At what annual percentage compounded quarterly should a lump sum be invested in order for it to double in 6 years? Okay, so this is just going to be the A equals to P 1 plus I to the N formula. Now let's let P equal X. So P is your starting amount. Then what would A be? Well, it says at what interest rate must we do so that we can double. So if P is your starting amount and you want to double that, then A would be 2x. So now we can go and say 2x equals to x, 1 plus. Now at what annual percentage interest rate? So we don't know. It's compounded quarterly. And it's 6 years. So that would be 6 times 4. And so what you can do here is you can just cancel the x's on both sides. So boom and boom. And so you end up with 2 equals to 1 plus I over 4 to the power of 24. Now, to get the I alone, you could take the square root of the 24th root on both sides. Okay. Now, technically, because this is a even number, we should be saying plus and minus. But we're probably going to have to get rid of the minus. But let's see how it goes. And so what we end up with now is plus minus, so 24 over here, 2. And then on the other side, we're just going to have 1 plus I over 4. So we don't actually need a bracket anymore. So what we can now do is we could take this 1 over to the other side. And then what we could do is we could multiply this 4 to the other side. So it'd end up with 4 multiplied by plus minus square root of 2, and that'll give you I. So I'm going to use the plus now, and then always remember to multiply your answer with 100 because it's a percentage. So I would be 11.72%, or I definitely don't think this next one's going to be valid. You can't have a negative percentage, but let's see. So I'm putting the negative in front of the square root now. Yeah, it gives you a negative value. So yeah, don't even worry about putting the plus and minus. They won't mark you down for that in this kind of section. And so you can actually just take that out. And or you can show it if you want, but they won't penalize you for this section for not putting the plus and minus. Okay, so the answer would be 11.72%. Michaela buys furniture to the value of 10,000 Rand. She borrows the money on 1 February from a financial institution that charges that interest rate compounded monthly. Michaela agrees to pay monthly installments of 450. The loan allows Michaela to start paying equal monthly installments from 1 August. Okay. Calculate the total amount owing to the financial institution on 1 July. Okay, so let's break this down. On 1 February, Michaela borrows money. Now, normally, if you've watched all the videos on present value and even on the future value, when do we normally make our first payments? Normally, it's after 1 month. So usually, we would make our first payment over here. Okay? Then it would be 1 April. You would make your next payment. So this would be your normal, or normally, your first payment. This would normally be your second payment, third payment, June, 1 July, and 1 August. Okay, now, Michaela only starts making her first payment over here. So how many payments did she miss? Well, you mustn't count this one, because normally we start over here. So she misses 1, 2, 3, 4, 5. She misses the first 5 payments. Now remember, if you've watched videos on present value, the value of the loan that she took out is 10,000 Rand. That institution, like the bank, for every payment that you're missing, remember that loan amount is going to keep growing, okay? So that 10,000 Rand is no longer going to be 10,000 Rand when she decides to make her first payment. She's going to log into her ABSA or her FNB account, see that the loan amount is no longer 10,000 Rand. Maybe it's now going to be 10,600, for example, because she hasn't started paying, but the bank's not going to wait for you. They're going to start adding on that interest. Okay, so the first question says, calculate the total amount that she owes to the financial institution. So obviously it's not 10,000 Rand anymore. So we're just going to use the grade 11 formula, and we're going to compound that 10,000 Rand for 9.5%. I like to write it like that, compounded monthly. And how many payments did she miss? 5. Okay, and so let's see. 10,402 Rand and 15 cents. So you mustn't say, yeah, but Kevin, we're starting here on 1 February, and then it's going to be 1, 2, 3, 4, 5, 6 months until 1 August. It doesn't work like that, guys. You got to think about how they normally do it in the real world. So in the real world, you normally start after 1 month. So they don't penalize you for not starting there. And then they're only looking at the payments that you miss, okay? So because she's starting here, they're not going to also count that part there. So the missed payments is 5. And so this is how much the new loan amount is when Michaela decides to start paying. This next question says, how many months will it take Michaela to pay back the loan? Okay, so we now know that we're not going to start over here now. We're now going to look at from when she starts paying, okay? So we're going to use the present value formula, which is P equals to x1 minus 1 plus I to the negative n over I. So now we're no longer using 10,000. We're now using 10,402.15. The monthly payment is 450. The interest rate is 9.5%, so 0.095. Okay, I'm not going to fit that in. And now, okay, so the number of payments we don't know. So we can actually just leave that as the unknown. And then we could just say 0.095 over 12. You see, so it's actually an easy question. Just don't use 10,000 because that's no longer valid. You got to make it valid from where we're starting. And now we're starting to make our payments here. So this is the amount you would use. And they're not saying like in what year would she finish or whatever. They just want to know how many months. And so you can literally just go work out the value of n now. And yeah, so let's do that. So what I would do is I would multiply this part over to the left, and I would divide this part on the left as well. And so that would end up giving us 10402.15 multiply 0.095 over 12 divide 450. And that's then equal to 1 minus, now this I'll type on my calculator, the 1 plus 0.095 over 12, but leave it as a fraction, okay? It's very sensitive because we're probably going to use logs just now, and your answers can change a lot if you start rounding off now. So leave it like that. Okay, type this on your calculator as well. It'll also give you a fraction. Let's see what that'll be. Oh, it doesn't give us a fraction. Okay, that's fine. Just want to double check. 0.095 over 12, 450. Okay, then just write all the decimals. Don't want to be rounding off at this stage. Okay, now I'm going to take this unit to the left and then bring this to the right. And so now we end up getting 2419 over 2400 to the negative n. We just brought this over to the left hand side, and then on the right hand side you're going to get that. Now I'm just going to quickly pop that on my calculator, and so we end up with 2419 over 2400 to the negative n equals to 0.816999213. Okay, now it's logs. So with logs, you take your exponent, you make it equal to log of your base. Your base always stays your base. Whether you're going from exponential to log or log to exponential, your base stays your base. So this was the base, and now it's still in the base position. So that's a nice thing to remember. And then 0.816999213. Okay, so it would look like, whoops, what did I just do? Like that. Okay, so let's go type that in. Okay, so that's going to give us negative n equals to negative 25.63. And so n would be 25.63. So what does that mean? Is it going to be 25.63 months? Well, no, you can't make 25.63 payments. So she's going to have to make 26 payments, where the last payment will definitely will be a little bit less than the normal. I'm surprised they didn't add 7.2.4 asking us to calculate what that final payment amount would be. We're lucky. This next question says, what is the balance of the loan immediately after Michaela has made the 25th payment? This last one says, what is the balance of the loan? That actually just means outstanding balance. So I'll start with the present value method. You only need to do one in the exam though, okay? And then I'll show you the future value. So with present value, this n value is payments you still need to make. Okay, so remember when we calculated n, I said 25.63, but when you use this method, you actually have to use the non-rounded method, the non-rounded value. So 6315128. So it says after we have made the 25th payment. So what you then do is you just say minus 25, and that'll give you the number of payments or the part of the payment that still needs to take place. I know we can't make that many payments, but that's the portion still left, and that is what we use here for this formula. And so you're going to say 450, 1 minus, 1 plus. The interest rate was 9.5%, and we are going to say 0.6315128, and that is all going to be over 0.095 over 12. If we calculate that, we get 282 Rand and 36 cents. Now, when you do future value, your outstanding balance is, you got to do two parts. It's the loan amount minus your future value of your payments. So your loan amount is just using the grade 11 formula, A equals to P1 plus I to the N. So that's just going to be your original loan amount, which was not the 10,000. You got to use the 10,000. It's from when we started paying. We know that we've done 25 payments from that moment. And then 1 plus 0.09. Okay, I'm definitely going to run out of space. Okay, I'm going to erase the present value because you get the idea. So it's here, future value. Okay, so we said that your outstanding balance is always going to be your loan amount, whatever that's become, minus your future value. So that's going to be, you're using the grade 11 a equals to p1 plus I to the n formula, and then this is going to be your future value. Now, with this formula, the n is the number of payments that are already completed. It's not the number of payments you still need to complete, it's the number of payments that have already been completed. Whereas when we used the present value, then it was different. Okay, so it's going to be the original, or the loan amount when we started paying. We've made 25 payments at this part. Our monthly payment is $450, and that's 25 payments. Okay, and that's it. So now you can just go type that on the calculator. That gives us 282.36. Sometimes it doesn't give the exact same answer as the present value method. Sometimes it's a few cents off. And there we go. Now some of you might be thinking, Kevin, why aren't we now taking this answer and compounding with one more month? That's a good question. That's only if they asked us to calculate, let's say they added a new question, 7.2.4, calculate the value of the final payment. Then you would have to realize that this number here is your outstanding balance after 25 payments. Your 26th payment is going to happen in 1 month, and that is where we would then compound using the grade 11 formula for 1 month. Maybe you've seen videos of mine like that before, but this question isn't asking that. They just want to know what is the outstanding balance immediately after that 25th payment. Here we have a first principle question. So we know that with first principles, we have to do the first derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. Now, remember, when they say f of x plus h, I'm going to show you what that looks like over here. It means that you take this expression, and wherever you see x, I want you to put a bracket. Okay, let's make a bit more space. And you're going to put x plus h in that bracket. That is what x plus h means. And then f of x, well, that's easy. That's just this expression over here. So now we're going to go fill everything in. So we're going to say limit as h goes to 0. And now we're just going to say minus 2x plus h squared plus 3x plus h. So you see there we've just filled in x plus h. Then we're going to say minus. Now I want you to put a bracket and fill in f of x, because now we're at this part. So f of x is just that. A lot of learners forget to put the bracket. There we go. Okay. Now we just want to simplify. And so here I would, please don't just put the 2 inside and say x squared plus h squared. You got to make double brackets. Like that, x plus h, then plus 3x plus 3h plus 2x squared minus 3x. I just multiplied this negative inside. Okay, over h equals lim. H goes to 0. Remember, they want us to write this all the way down. And so here, when I have 1, 2, 3 things that I'm multiplying, I would always multiply the 2 brackets together. So x squared plus 2xh plus h squared. You might say x squared plus xh plus xh, but I'm just putting them together in one step. But you don't have to do it that way. And then I can already see that this 3x and this 3x is cancelling, so I'm going to just cancel that. Or let me keep it for now. You'll see why. I want to just explain something just now. Okay, and now we're going to multiply the 2 into the bracket, so that'll be minus 2x squared minus 4xh minus 2h squared plus 3x plus 3h plus 2x squared minus 3x, and that's all over h. Okay, now as I've said in many of my first principle videos, at this step you would like everything that doesn't have an h to cancel. If that doesn't happen, something has gone wrong. So this one cancels with that one. This one cancels with that one. So there we go. Okay, now we say lim h goes to 0 of minus 4xh minus 2h squared plus 3h over h. We now take out h as a common factor. So I'm just going to write it over here, but you would imagine that I would write it, I'd keep going downwards. H goes to 0, take out an h. If there's more to take out, don't even worry about it. You just need to take out the h. Okay, and now the h's cancel. That's a good thing. Now I'll carry on up here, equals lim as h goes to 0 of minus 4x minus 2h plus 3. Now we can let h go to 0, and that's going to equal minus 4x minus 2 times 0 plus 3, and that'll be minus 4x plus 3. The only reason we can't make h 0 in any of these steps is because we have an h in the denominator, and that's undefined. But as soon as we get to this part, the h cancels, then we can go make h 0, and from that point onwards, we no longer have to say limit h goes to 0, because now we are letting h go to 0. And so here's our answer. Now, if I gave you this question and I said, please take the first derivative, but you could use the FOST method, that would also give you minus 4x plus 3. It must be exactly the same. Given this expression, calculate that. Now, all that they mean here is that all they want you to do is take the first derivative. Once you've taken the first derivative, let x equal to 9. Okay, so to take the first derivative here, we just need to make a few modifications first. We can leave that 2 at the bottom, that's fine. You might feel more comfortable writing it like that. And then x square root is the same as x half. Okay, now we can take the first derivative, very easy. Now we're just going to take the 2, multiply it with the number in the front, that'll give you 3, and then you're going to subtract 1. Then you're going to move on to the next part where you're going to multiply this with the number in the front, that'll give you 12, and then you're just going to subtract 1 from here, which will be negative a half. Done. Now, they just want you to now go and put 9 in the place of x. Okay, and so that'll be 27. Now, we know that 9 to the negative a half is the same as 9 to the half, just by putting it at the bottom. And we know that a half exponent is the same as a square root. So we could even do it like that. And so if we go calculate, that'll be 27 minus 12 over 3, which would be 27 minus 4, which is 23. A function g of x equals to ax squared plus b of x has a minimum value when x is 4. The function value when x is 4 is 96. Calculate the values of a and b. So I know that when a lot of you look at this, it's overwhelming. But look at this, guys. They're telling us that when x is 4, the function value is 96. So when x is 4, the y value is 96. So let's start with that immediately. We'll plug in 4 for x and we'll plug in 96 for y. Then I would just simplify this a little bit. So 16a, because that gives me 16, plus b over 4. That can be our first equation. They're telling us that it has a minimum value. How do we normally find minimum value? You take the first derivative and you make that equal to 0. So we will do just that. So we've got g of x equals to ax squared plus b over x. But now to take the first derivative, we want that x to come to the top, like that. Now we can take the first derivative. So you multiply this 2 to the front, so that'll become 2a. And then you're going to just subtract 1 from this exponent, so that'll just be a 1. And then this minus 1, you're going to multiply to the front, so that'll become minus b. And then you're going to subtract 1 over here, so that'll become negative 2. Now they told us that at that point, x is 4, and we know that we should make the first derivative a 0. So we make it a 0, we plug in x is 4, and there we go. So now I just want to rearrange this a little bit. This will become 8, and then this will become b over 16 because I'm taking this 4 to the minus 2 down. And so now we have two equations, two unknowns. We all know where we are now. So what I'm going to do, there's multiple ways you could do this, but I'm going to, let's see. Okay, I'm going to get b by itself in this equation. So I'm going to bring the 16a over. I'm then going to multiply everything by 4. So 384, so I'm multiplying this 4 over, minus 64a equals to b. And then on this side, I'm also going to get the b by itself. So I'm going to bring b over 16 over. So many different ways you could do this. And then I'm going to multiply the 16 to the other side. So that'll become 8 times 16, which is 128. And then all of a sudden, we've got an expression for b. And so I can make both expressions equal. Okay, I'm then going to take the 64 over, where it'll become 192a. And then if you divide both sides by 192, you would find out, therefore, that a is 2. And then to get b, you could just plug it into this expression over here or over here, wherever you like. So b would then be 128 multiplied by 2, and so that would be 256. The graphs of g with the first derivative. Okay, so that's going to be quite interesting. So that's the first derivative of some other graph called g. And h are sketched below. The graph of g is the derivative graph of a cubic function. Yes, of course. If you have a cubic function and you then take the first derivative, you end up with this, okay? The graphs of h and g have a common y-intercept at point E. C and D are the x-intercepts. Point A is the x-intercept. Line AB is parallel. Okay, so first question, write down the coordinates of point E. So that'll be easy because you can just use this equation over here and you just need to go find its y-intercept, and you can do that by just making x equal to 0, and that'll give us negative 4. So the coordinates of E would be 0 and negative 4. Now it says determine the equation of this graph. Okay, so we know that it's a parabola, and in grade 11 we learned two ways to find the equation of a parabola. Either they've given you the turning point, then you would use this equation, or they've given you the two x-intercepts, and then you would use this equation. So we can see that they've given us the two x-intercepts. So we're going to say y equals to a, x minus 6, x minus minus 2. So that becomes x minus 6, x plus 2. Now for a, you need another point. So we can use this point E, which is 0 and negative 4. So the negative 4 is the y, the x is 0. Okay, and so negative 4 is equal to a. Now just put these two brackets together. You don't have to multiply them out. Just say negative 6 multiplied by 2, which is negative 12. Then to get a alone, you're going to divide by negative 12, and you're going to get 1 over 3 as your a value. Some of you might say a is 3, but then you're just doing it the wrong way around. Okay, so we have a. So now what we're going to go and do. And notice that a lot of learners are not comfortable with this in grade 12, where they have this parabola that has it's the first derivative. But notice that we haven't had to use that yet. And we've already got 1 plus 4. We've already got 5 marks out of a total of 10 for this question. We already have 50%. So you don't have to stress when you see that and think, oh no, I don't know how to use that, because a lot of learners don't. But we haven't had to use that yet, and we already have 5 out of 10. Okay, so let's quickly go say a third, x minus 6, x plus 2. So now let's leave the 1 over 3 there, and then let's multiply this bracket out. So that's going to become negative 4x, because it's plus 2 minus 6. You can do it in different steps if you want. Minus 12. Then we're going to multiply the 1 over 3 into the bracket. Minus 4. So I just multiplied that third into each of those three things. Now this next one you need to pay careful attention to. It says, write down the x-coordinate of the turning point of G. They're not talking about this graph. A lot of you are going to say, oh, there's the turning point. Or you're going to go work out the turning point from this equation. Not correct at all. They're not saying, remember that this graph here is g of x with the first derivative. You see it even says it there. But they're asking specifically about g, which is the original graph. So think about this. How do we normally find turning points? That is normally when the first derivative is equal to 0. So here we have the graph of the first derivative. This is the graph. So where is it equal to 0? It is equal to 0 over there, and it is equal to 0 over there. It's not the turning point of this graph that we're looking at. So it is equal to 0 over there, and so you would say x equals to -2 or x equals 6. This question says, write down the x-coordinate of the point of inflection of the graph of g. Okay, so we know that to normally find an inflection point, we need the second derivative, and we want that to be 0. So because we have this equation, remember this is our first derivative. This is actually our first derivative. Then all we need to do to go from our first derivative to our second derivative is just take the derivative of this once. And so to take that, remember that this number here is going to multiply to the front. That's going to be 2 over 3, x to the 1, minus, then this part here just becomes 4 over 3. And then this part falls away completely. Now we're going to make that equal to 0, because that is how we find inflection points. Now because we have a common denominator of 3 and we have an equation, we can actually ignore that. So we can actually just say 2x minus 4. And then however you want to solve this, you should eventually find out that x is 2. X is 2. With this last question, it says explain why g, so g is the original cubic graph. G is not this graph over here, okay? Explain why it has a local maximum at x equals -2. So don't worry too much about the word local, but why does it have a maximum? So remember, a maximum is a graph that does this, and then a minimum is a graph that does this. Now remember, you mustn't look at the shape of this graph, because then you're going to say, oh, it's a minimum. But remember, this is not the graph of g. This is the graph of g, or first derivative. So they're saying that x equals to -2. So what I want you to look at is when x is smaller than -2, look at these y values. They're positive, right? So we can say that when x is smaller than -2, we know that that graph is positive. We can see it's got positive y values. But what does this actually mean? What does the first derivative mean? What if I told you guys the first derivative actually means? It's another name for the gradient. So therefore, when x is smaller than -2, the gradient of the original graph is bigger than 0. Then, when x is bigger than -2, so when x is here, then we can see this graph becomes negative. Then we can say that g of x becomes negative. Therefore, we can say the gradient of the original becomes negative. So when you are at this point -2, we are going from a positive gradient, which looks like this, to a negative gradient, which looks like that. So it means that at the point -2, we must be having a turning point. So let me rather show this a bit better. So on the left-hand side, we've got a positive gradient. And on the right-hand side, we would have a negative gradient. And so it must be a turning point maximum over there, because the gradient is switching from positive to negative. And so, therefore, g is a local maximum when x is -2. If you wanted to understand this a bit further, so that's the end of that question, but for those of you that are more interested, if you look at this part over here, we would see the exact opposite. On the left-hand side, we could see that the g of x is negative, which would mean the gradient of the original graph is negative, even though the gradient here is positive. We're not looking at the shape of this graph. And then on the right-hand side, so we could say here on the left-hand side, sorry, that the gradient is negative, or the graph is negative, which means remember that this represents the gradient of the original. And then on the right-hand side, we can see that this is now becoming positive. It's got positive y values. But this here represents the gradient. So the gradient is negative over here, negative over here, and then positive over here. So that would be a minimum, because you're going from a negative gradient to a positive gradient. So this is where you would have a minimum on that graph, and this is where you would have the local maximum on the graph, on the original graph of G. Given that h of x is equal to 4x cubed plus 5x, substantiate whether it is possible to draw a tangent to the graph of h that has a negative gradient. Well, they're trying to make it confusing, but it's actually very easy. We know that the gradient of a tangent is the same as the gradient of the graph at the point of contact. So for example, what I mean is that if you have a graph like this, if you have a tangent, let's say for example you have a tangent over here, then at that point of contact we can see that the gradient of the tangent and the gradient of the graph is exactly the same. We know that. So they just want to know, actually, determine whether it's possible to have a tangent that has a negative gradient. That would only be possible if this thing over here can have a negative gradient. So let's see if that thing can ever have a negative gradient. So can h of x ever have a negative gradient? So is that smaller than 0 possible? Because this means gradient, right? That's the first derivative. And is it possible that it could ever be negative, which is smaller than 0? And so we'll go take the first derivative, which is going to be 3 times 4 is 12, x squared plus 5. And we want to know, can that thing ever be negative? So can that ever be negative? And the answer is no. It can't ever be negative. You could try solve it, it wouldn't work. But let me try explain to you from a basic perspective. We know that whatever you put inside here will always be 0 or positive. It can never be negative. Why? Well, if you put any negative number or any positive number and you square it, it becomes a positive. So if you say, for example, minus 8 squared, it becomes 64. If you say minus 100 and you square it, it becomes, what, I don't know, 10,000 or something. It always becomes a positive. If you put a 0, well, then it becomes a 0. So this expression here would either be 0 or something positive. So even if it was 0, then if you go and add 5, this expression can never, ever, ever be negative. So we can say that x squared is always going to be bigger than or equal to 0 for all x values. Okay? So 12x squared plus 5 will always be bigger than 0. It won't even be able to be 0, because even if this part's 0, but then you're adding 5, so we'll say that that part is always going to be positive for any x value. So therefore, this expression can never have a negative gradient, so any tangent would also never be able to have a negative. You can't draw a tangent that's going to have a negative gradient when your graph doesn't have a negative gradient. What does a graph look like that doesn't have a negative gradient? Well, maybe it's doing something like this. So you see the gradient always positive. So no matter where you draw a tangent, that tangent would always have a positive gradient. So the answer is, therefore, not possible. Not possible. And even if you tried to solve this expression, it would never work. You would end up trying to take the square root of a negative number, which will just give you an error on your calculator. The diagram below shows the plan for a veranda which is to be built onto the corner of a cottage. A railing A, B, C, D, E is to be constructed around the four edges of the veranda. It is given that AB is equal to DE. Okay, so AB is equal to DE. So AB is equal to DE, which is X. And BC is equal to CD, which is equal to Y. And the length of the railing, sorry about this, must be 30 meters. 30 meters, okay? So the railing, where's the railing? A, B, C, D, E. So A, B, C, D, E, okay? So the railing must be 30 meters, and the railing is from A to B to C to D to E. So that must be 30 meters. Calculate the value of X and Y for which the veranda will have a maximum area. Okay, so as always with these questions, what we do is we always start with what they want. So they want the maximum area. So we go find the area formula. And it's quite interesting. It's not a perfect rectangle. So if it was a perfect rectangle, then you would say it would just be this length multiplied by this length. So let's start with that. But then we're going to have to minus this piece over here. So what would this length be? Well, this length would just be y minus x, because that's y and that's x. And then this length over here would also be y minus x, because this part here is y and that part's x, so it would just be that. So this is a square, so you could just say y minus x times y minus x. Okay, I hope that that makes sense. We've taken the area of the whole thing, but then we just had to minus this little piece so that we only have the veranda part. Okay, now as always, we just want to go neaten this up a little bit. So y squared, take away xy, take away xy, plus x squared. I just multiplied this all out. I kept it in a bracket though because of this negative. And so if I go simplify now, I end up with y squared, take away y squared, plus xy, take away x squared. Okay, so these cancel. And so the area is then going to be xy, or 2xy, minus x squared. Right? 2xy's, and then minus x squared. Now, to find a maximum or a minimum, we normally want to take this expression, find the first derivative, make it equal to 0. But the problem we have is that we've got two variables. We've got x and we've got y. So because we have two variables, we know what to do. We have to go find other information. So they've told us that the railing is 30 meters. So that means that it's like the perimeter. So if you say that x plus y plus x, I just said this, plus this, plus this, plus this, that must add up to 30. And so we could say 30 is equal to 2x plus 2y. We could divide everything by 2, and that would give you that. Now, we don't want this y. I want to find x, or it says calculate the value of x and y. So it doesn't really matter what you want to do. And so replacing that y, I'm going to take this equation over here and I'm going to get y by itself. So that would eventually give us y is equal to 15 minus x. So I'm now going to take this and I'm going to plug it in over here. Okay, so we're going to say that the area, I'm just going to call it A actually, the area with respect to x, because now we're only going to have x's, is going to be 2x bracket 15 take away x minus x squared. Now we're going to simplify, because we know that to find minimums and maximums, we know that we eventually have to take the first derivative. And to take the first derivative, we're going to have to get to a place where the expression is simplified. So that's going to give us 30x take away 2x squared take away x squared. Simplify a little bit further, 30x take away 3x squared. Okay, now we can take the first derivative, so we can just show it like that, for example. And so that would give you 30 take away 6x, because we know that this x falls away, and then these two you multiply together, and then you subtract 1. Okay, now we know that when you want to find maximums or minimums, makes no difference. You make the first derivative equal to 0. Now we're just going to solve for x, so 6x equals to 30. Divide both sides by 6, x is 5. Now to find y, come back to here. So we know that y is equal to 15 take away x. So y is equal to 15 take away 5. And so y is equal to 10. And so there we have the value for x and y. And that's it. They didn't even ask us what the area was. But if they did ask us what the area was, you could then just plug it into any expression, really. You could plug it into this one, 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 you could plug it into this one. Any of them, because all of them are area. You wouldn't plug into this one because that's not area, that's the first derivative of the area. Let A and B be two events in a sample space. Suppose that the probability of A is 0.4, A or B is 0.7, and B, probability of B is K. For what value of K are the events A and B mutually exclusive? Okay, so mutually exclusive means that A and B, let's actually say here, mutually exclusive. Think of the word excluded. We know that included means that you allow things to be apart. So if you include someone into your friend group, you're allowing them to be a part of your friend group. When you are excluding, it means that you are telling, or you're pushing things away, or you're not allowing things to happen, or you're not allowing the friend to be part of your friend group, or something like that. So when things are mutually exclusive, it means that A and B cannot happen at the same time, or cannot happen, at the same time. It means that the probability of A and B must be 0. Visually, on a Venn diagram, mutually exclusive looks like this. Can you see that the part where they intersect does not exist? Okay? Because normally the part where they intersect, we call that the A and B. That's A and B. But we've just said that with mutually exclusive, this part must be a 0. How do you make it a 0? By pulling them apart like that. Okay, so now we're going to go back to the basic probability formula that we've learnt about in grade 11, which goes like this. Let's say the word or. It's on our formula sheets as well, and B. So we know that this one is 0.7. They told us up here. We know that this one is 0.4. We know that this one is K, and we know that this one must be 0 because we've just said if it's mutually exclusive, that part must be a 0. And so if you had to go solve for K now, you would get 0.3. This next one says, for what value of K are A and B independent? Now, independent, you must remember, it just means the following. It means that the probability of A and B is equal to the probability of A multiplied by the probability of B. Okay? That is what independent means. So what we'll go and do is, once again, we'll go use this formula. And we'll still say 0.7 over here. We'll still say 0.4. We don't know what that one is. But now for this part, we can say that it's the probability of A multiplied by the probability of B, which will be 0.4 multiplied by the probability of B, which is a K. And so now we can just say 0.7 equals to 0.4 plus K minus 0.4 K. These two together will become 0.6. Some learners get very confused with that. Remember, there's a 1 here. So 1 minus 0.4 is 0.6. I'm going to take this over to the other side. So that'll become 0.3. Okay. You're then going to divide both sides by 0.6. And you should get an answer of a half. You mustn't get an answer of 2. Then you've done this part in the opposite direction. So K would then be a half. The data obtained from a city's police department indicates that all motor vehicles reported, indicates that of all motor vehicles reported stolen, 80% were stolen by syndicates to be sold off, and 20% were stolen by individuals for personal use. Okay. Of the vehicles presumed stolen by syndicates, 24% were recovered, 16% were recovered after FODA, 60% were never recovered. Of those, okay, so draw a tree diagram. So all it does, guys, you can see that here's the first category. This is category number 1. So all we'll do is we'll start our tree diagram, and we'll make 2 lines. And they will say 80% or 0.8, and 20%, 0.2, and then we can just name it syndicates, and then down here were individuals. Okay, now once we are in the syndicates category, we're now going to have 3 different categories. So we're going to go boom, boom, boom. And once we are in the individual category, we're going to go 3 categories, boom, boom, boom. And so we're going to say 24% were recovered within 48 hours. That'll be 0.24. And let's call that within 24 hours. Then we're going to say 0.16. And that's going to be after 48 hours. And then 60% were never recovered. So let's just say never. Okay, now same in the bottom one, 38%. So we'll just say 0.38 within, so I don't know why I said 24, within 48, within 48, 0.58 after 48, and then 4%, which is 0.04, never. Okay, so there's the tree diagram. Fantastic. Now, calculate the probability that if a vehicle was stolen in the city, it would be stolen by a syndicate and within 48 hours. Super easy. Syndicate and recovered within 48 hours. There we go. So we've learned that in order to find the probability of a branch, you multiply all the different branches in that section. Okay, so we're going to say 0.8 multiply 0.24, and that'll give 0.192. Okay, now calculate the probability that a vehicle stolen in this city will not be recovered. Okay, so where do we find the not recovered parts? Well, that would be there and there. So what you do is you first need to go get the total for the yellow one. So for the yellow one, it would be 0.8 multiply 0.6. Then you're going to say plus. Then you're going to go get the total for the green one, which is going to be 0.2 multiply 0.04. Add this up, and you should get 0.488. Why am I using 3 decimals? Well, I know that in the exam papers they typically say 2, but it's very weird. When your calculator gives you an answer where the decimals end, like if you go look at these answers, the calculator literally goes up to there and the calculator literally goes up to there. Then it's fine to just add all of that like that. You have to choose a password for your new Facebook profile. Yeah, because teenagers in high school still use Facebook. I barely use Facebook anymore. I'm all about the gram now, brother. Okay, you have to choose a password for your new Facebook profile. My grandparents and my parents still use Facebook. Old timers. Okay, you have to choose a password for your new Facebook profile. The password must be in the format of where that is any digit. Zeros are not allowed. And the ats are any vowels. Okay, let's talk about that because they've made this really weird. Jeez, man. Why are we using these funny symbols? The person who set this up is into that weird kind of stuff, like that hieroglyphics kind of stuff. Okay, so the first part of here, these are all digits. So these are digits. But you're not allowed to use 0. So what digits can you use? 1 to 9. Okay, and then these over here are the vowels, you know, A, E, I, O, U. You may repeat the digits, but you may not repeat the vowels. Okay, how many passwords can you form? Very, very, very easy question. So we've got the digits 1 to 9. So for this first one, how many different digits could you choose? Well, 9. For the next one, don't say 8. Kevin, why? It said you may repeat the digits. So you can choose any of the 9 again. And then for the next one, you can choose any of the 9 again. Now for the letters, we've got 5. A, E, I, O, U. So there's 5 options over there. Now for the next one, there would only be 4 because they said you must not repeat a vowel. So then we just multiply all of these, and this should give 14,580.